So this is a problem on conditional distribution. So the question is, there is an insect which lays eggs, and then the eggs become larvae. It lays a large number of eggs, say x. We have to assume some things about it, that x is a random variable. Let's say it has a Poisson distribution with lambda parameters. So probability of x is equal to x is going to be g of x. This is going to be lambda x e minus lambda and x factorial. So that's the Poisson distribution. But x then become larva, but only some of them become larva. So y, so they can become yes, success, you become a larva, and if you don't, then you die. So it's like a coin toss. When you get a head, you become a larva, and when you get a tail, you die. Let p be the probability that it will produce a larva, then this is a y is a binomial, then pi becomes a binomial random variable where x is the total n. So y given x is a binomial with parameters of x and p. So f y given x is going to be x y p of y and 1 minus p x minus y. Now we are going to do we'll go all the way and we'll calculate the expected value of y. Now we know that expected value of y is law of iterative expectations, expected value of y given x. Now we have seen this, it is a binomial variable, y is a binomial parameter, so the expected value is going to be x and p comes out, so it becomes expected value of x. Now x is a Poisson distributed. In this case, x is Poisson distribution, so expected value of x in Poisson distribution is lambda, so expected value of y is going to be lambda p. Okay, now we're gonna go into variance of y. Variance of y we know is going to be variance of expected value of y given x plus expected value of variance of y given x. Variance of y is variance of expected value of y given x and expected value of variance of y given x. Now expected value of y given x is just xp, and variance of y given x is a binomial variable, so it's going to be xp 1 minus p. So variance xp plus expected value of xp 1 minus p. Now this p square will come out, and then it will become variance of x plus p 1 minus p expected value of x. Variance of x is same as the expected value of x, which both is lambda for Poisson distribution. So it becomes p square lambda plus p 1 minus p lambda or you can take the lambda here and it becomes p square plus p minus p square. So this all cancels and the variance of y becomes lambda p. So now we have variance of y, we have the expected value of y, they're both lambda p.